Welcome to this lesson. So in the last lesson we looked at how to go about filling values in our empty nodes. So we filled the first value in here by choosing the maximum value of these two. Now let's go for the next one. So for the next one, that is the next maximizing child node, we have these two to choose from, 3 and 2, and the maximum value of that is 3. Now let's go for the next. So for these two, the maximizing value is 10 and 12, and the maximum of those two is 12, so we filled it with a 12. And for the next, -4 and -5, obviously the maximum value of that is -4, so we've chosen -4 in here, and we filled with that as well. So now we can start filling the minimizing states, that is these states, okay? So for the minimizing states, it's quite obvious, isn't it? So there's 5 and 3, and out of 5 and 3, the minimum value is 3, so this particular child node is going to have 3, and 12 and -4 is going to be -4 because the minimum value is going to be -4, so this is going to be filled with -4, right? So, and finally, we need to choose the root node. We need to choose a value for the root node, and it is going to be a maximizing value. So 3 and -4, it's going to be 3 because the maximum is 3. So great. So now we have the optimum result. Okay, so we know what the optimum result is going to be after both the maximizing and the minimizing players finish playing. So 3 is the best possible value the AI player can hope to achieve so that the final chosen value isn't too low. See, best value is going to be 12. Or at least 10, but we're not getting that because the minimizing player is gonna try to minimize our value, so at least it's not a -1 or a -4 or a -5. So we've gotten the best possible value that we can get when the minimizing player is also playing. Okay, that's how adversarial games work. So in the adversarial game, someone is always going to make sure that you get the least possible value, so you have to get the best possible result, that is the optimal result. Okay, so 3 is the best possible value the AI player can hope to achieve. So now the AI player knows that in its current turn, it has to choose the left node. Because since it has 3 in here, it will know that it has to choose the node that is pointing to 3. So it knows it has to choose the left node. So it has to make the move that goes to the left node, which will lead to the final result being 3. So since our algorithm has already analyzed all the moves, it has drawn the tree, and then it's filled everything. So now it'll do all of that before the game even starts. So now it knows where it needs to go. So the first player is the AI player. What your MiniMax algorithm is going to think is, okay, fine. So this is how the tree is. So this is what I need to do. So, okay, it's the AI's turn now. It's going to instruct the AI, and it will tell that, okay, the first possible move you have to do is go to the left side. So choose the move that goes to the left side, and the AI player will do that. Okay, it's gonna go to the left side. And then next, let's say our human player chooses the right node, because for the human player, it's gonna analyze and it's gonna say, oh my god, if we go this side, the player is gonna choose 5. Okay, but if I go this side, it'll choose 3. So that's a lesser number than 5, so it's gonna go this side, because if your human player is an intelligent player, they'll probably think like that. Okay, so it's gonna choose the right node. And finally, for the last particular move, our AI player is going to choose the 3, and then it'll finally land on 3. So that's going to be the final state of the game. So the AI player, after analyzing the entire game tree and understanding which moves leads to which end states, chooses the left node, which is the optimal next move. So that's how it chooses next move. Okay, so essentially the AI player will play on the same level as a very intelligent human being. So they'll both look multiple moves ahead, that is a human player and the AI player. They'll analyze the results their next possible moves will bring, and it'll choose the optimal next move. And since the moves ahead are only 2 or 3 moves ahead, the human player can easily play. But if it's 10 moves ahead, if the end state is at 10 moves ahead, 20 moves ahead, 50 moves ahead, then you can obviously see that the AI player will have a higher chance of winning because it can actually look 10 moves ahead, while the human player can't possibly look at all the possibilities of 10 moves ahead, right? So right now, in a simple game like this, the human player is going to be very intelligent and it's going to play at the same level as an AI player. But as the complexity of the game increases, a human player is going to start making mistakes. Okay? So in ideal situation, neither the intelligent human nor the AI will win in an adversarial game. As you can see here, we are ending at an average number. So it isn't low like -5, it isn't high like 12. So we are ending up with an average number. So it essentially means that it's a draw. No one wins actually. Okay? So that's what happens when both the players are intelligent. But as the complexity increases, the intelligence of the human player is going to be taken to task, so the AI player has a higher chance of winning. So finally, the maximizing player will choose 3 because it's the maximum value. There you go. It's the optimal result that both the maximizing and the minimizing player can bring forth. Do you see how it's neither the lowest nor the highest? That's because both the AI player and the human players played intelligently. If the human player had made a mistake in any turn, then the AI player would have easily ended up in one of the higher final states. For example, let's say the human player chose the left node. Okay, so let's say they chose 5 instead of 3. So they chose this particular node instead of the right node. And the next move is the AI player's move. So then the AI player would immediately choose the node 5, for the final state. That's definitely the bigger number than 3 that the AI would have chosen otherwise. Am I right? So that's how the MiniMax algorithm works. Okay? So let's look at another example and let's look at a more real world example in the next lesson. I'll see you there. Thank you.